A post on Our Mechanic Advice went viral last month. A mechanic wrote that a 2022 Ford Escape came in with 67,000 miles. The customer complained about a rough idle and a check engine light. The mechanic pulled the upper intake manifold. It had cracked completely in half. The entire intake manifold on a 4-year-old engine is injection molded plastic. Replacement from the dealer was $1,100 for parts and labor. The customer asked if this was normal. The mechanic did not know what to say. The replies came in fast. Mechanics across the country, same engines, same plastic, same failures, same stunned customers. This is not a supply chain problem. This is not an engineering accident. This is the cost-cut trap, and it is running inside the engine bay of almost every new vehicle on the road today. Today we are exposing exactly how manufacturers replaced cast iron and forged aluminum engine components with injection molded plastic. They did this to cut production costs by hundreds of dollars per vehicle, while charging you more than ever for the finished product. We are going to show you the specific components, the specific failure modes, and the specific reason why plastic has no business being anywhere near a combustion engine running at operating temperature. And we are going to show you what smart buyers are doing to avoid paying over $1,000 to replace a part that cost the manufacturer a fraction of what the aluminum original did. Here is the engineering reality that every manufacturer hopes you never understand. A modern gasoline engine runs at coolant temperatures between 195 and 220 degrees Fahrenheit under normal operation. Under hard acceleration or towing, underhood temperatures around the intake manifold regularly exceed 250 degrees Fahrenheit. Cast iron and forged aluminum handle these temperatures for decades without structural degradation. Injection molded thermoplastic begins losing structural integrity at sustained temperatures above 200 degrees Fahrenheit. It becomes brittle. It develops micro-fractures along the weld lines where the mold halves join during manufacturing. It expands and contracts at a different rate than the metal it bolts to. And every thermal cycle, every cold start followed by full operating temperature, weakens those weld lines incrementally. The engineers who spec these components know this. The thermal testing data is in the design file. They built it anyway. Industry analysts estimate injection molded plastic components cost manufacturers 80 to 90% less than the cast aluminum parts they replaced. On a production run of 500,000 engines per year, that difference represents tens of millions of dollars in annual savings per engine family. That savings goes directly to the manufacturer's bottom line. The thermal failure goes directly to your repair bill. Let us start with one of the most widespread examples. The Ford 2.0 EcoBoost 4-cylinder. The engine fitted to millions of Escapes, Fusions, Edges, and Focus ST models from 2012 through the present. The upper intake manifold and the thermostat housing on the 2.0 EcoBoost are injection molded plastic assemblies. At 60,000 to 90,000 miles, mechanics across the country report the same failure pattern. The thermostat housing develops hairline cracks along the injection mold seam lines. Coolant weeps into the engine bay. The manifold begins drawing unmetered air into the combustion chamber. The powertrain control module sees an AIR fuel ratio imbalance it cannot correct. The check engine light illuminates. The engine runs rough at idle. And the repair quote from the Ford dealer starts at $800 and climbs quickly from there. Forum user EcoBoost betrayed Escape documented his experience on a Ford Escape owners forum referenced constantly in these communities. I have 71,000 miles on my 2019 Escape 2.0. Dealer told me the thermostat housing had cracked and the intake was warping. I asked them to show me the parts they pulled off. I held them in my hands. They weighed less than a coffee mug combined. I paid $34,000 for this car. The components managing coolant flow and air intake into my engine weigh less than a coffee mug. He is not exaggerating. Hold a cast aluminum thermostat housing from a 1998 Camry in one hand. Hold the plastic unit from a 2019 Ford in the other. The difference in weight tells you everything about the difference in lifespan. The GM 2.5 and 2.0 turbocharged 4-cylinder engines fitted to the Malibu, the Equinox, and the Terrain run an injection-molded plastic valve cover as the primary oil containment surface on top of the engine. not a stamped steel cover with a replaceable rubber gasket. An injection-molded plastic housing with a permanently bonded gasket engineered to be non-serviceable by design. When that gasket fails, and it fails on the majority of these engines between 70,000 and 100,000 miles, you do not replace the gasket. You replace the entire plastic valve cover assembly. At the GM dealer, that assembly costs $340 for the part alone. The cast aluminum valve covers on pre-2010 GM 4-cylinder engines were resealed with a $12 gasket from any parts store in 45 minutes. The plastic cover on the modern version requires a $340 dealer assembly because GM designed out the ability to service it independently. That is not an engineering decision, that is a revenue decision. You might think this problem is limited to American brands. Think again. The BMW N20 and N26 4-cylinder engines fitted to the 328i, 428i, 528i, and X3 use a plastic oil filter housing that integrates the oil cooler, the oil filter cartridge, and the coolant crossover passage into a single molded unit. When that plastic housing cracks, and BMW technicians report it cracks on the majority of these engines between 80,000 and 120,000 miles, it does not just leak oil. It allows engine oil and coolant to mix inside the same passage simultaneously. Your oil turns to brown sludge. Your coolant turns brown. Both systems become contaminated at the same time from a single plastic component failure. BMW dealer replacement for the complete assembly is $600 installed. A mechanic named Oil Sludge N20 posted on a BMW owner's forum. I have seen this exact failure on 11 different N20 engines in the last 18 months. Every single customer believed they bought a reliable German car. Every single one of them had a plastic housing holding their engine oil and coolant apart. I showed one customer the failed part. He said it looked like something from a garden hose fitting. He was right. That is exactly what it looks like. And that is exactly what gave out. Now here is the detail that turns poor engineering into something deliberate. Manufacturers track warranty return rates on every component in every engine family. They know the plastic thermostat housing on the 2.0 EcoBoost fails at elevated rates between 60,000 and 90,000 miles. They know the plastic oil filter housing on the N20 fails between 80,000 and 120,000 miles. They know the plastic valve cover on the 2.5 Equinox fails between 70,000 and 100,000 miles. And in every case, the standard powertrain warranty expired at 60,000 miles. The failure window opens exactly where the warranty closes. These components were not spec'd to fail. They were spec'd to survive the warranty period and begin failing in the first service cycle that costs you money rather than costing the manufacturer money. You might think at least the production cost savings get passed on to the buyer. They do not. The average new vehicle transaction price in 2025 is higher than at any point in automotive history. The manufacturer captured every dollar of those material savings. The buyer received the $800 repair bill when the plastic part cracked at 71,000 miles. A forum user named Plastic Engine No More posted last week. I run fleet maintenance for a logistics company. We operate 200 vehicles. Every single plastic intake and housing failure we have had is on a vehicle purchased after 2015. 0 failures on anything older. 0. I switched to buying pre-2012 vehicles for our fleet specifically to get away from plastic engine components. Repair costs dropped 40% in 2 years. That is not luck. That is the cost-cut trap running in reverse the moment you stop buying into it. So what are smart buyers doing right now? Smart mechanics are cross-referencing engine designations against known plastic component failure patterns before any purchase is signed. The Ford 2.0 EcoBoost thermostat housing and intake manifold. General Motors 2.5 and 2.0 turbo non-serviceable valve cover. BMW 20 plastic oil filter housing. The Chrysler 3.6 Pentastar plastic water pump housing fails between 70,000 and 100,000 miles on the Jeep Grand Cherokee, the Ram 1500, and the Dodge Durango. The Volkswagen EA88 plastic thermostat housing warps and splits on the Jetta, Passat, and Tiguan after 60,000 miles. Every one of these failures is a documented pattern where a plastic component replaced a metal one, putting the manufacturer's savings on the balance sheet and the failures on your repair estimate. Smart buyers are spending $150 on a pre-purchase inspection from an independent mechanic who physically checks every plastic housing visible in the engine bay for heat discoloration, micro-cracking, and seam separation. Plastic running near its thermal limit develops characteristic darkening and brittleness at stress points, long before it fails completely. That inspection has saved smart buyers thousands of dollars in post-warranty repair bills on vehicles that looked pristine on the surface. And here is why the window to act is narrowing now. The 2025 tariffs on imported aluminum and steel components are already pushing prices higher for the cast metal replacement parts used in vehicles built before 2012. The aftermarket suppliers who manufacture cast aluminum valve covers and metal thermostat housings for older engines are seeing material costs rise. That $12 gasket and that $45 aluminum housing will not stay at those prices under the current import tariff structure. Smart buyers are sourcing and stockpiling the metal replacement components for their older vehicles now, before the tariff impact finishes moving through the supply chain. Because an engine built before 2010 with a metal valve cover and a cast aluminum thermostat housing is still infinitely cheaper to maintain than a 2024 engine with a plastic one, even after the metal parts price increases. The math only runs one direction. The manufacturers built the cost-cut trap because every dollar of material removed from your engine is a dollar added to their quarterly earnings report. They built it because the warranty closes before the plastic does. They built it because the plastic engine cover hides the plastic components underneath until the check engine light reveals them. You paid full price for an engine built with components that cost the manufacturer a fraction of what the metal originals did. The savings stayed in their boardroom. The repair bill arrived in your driveway. Have you had a plastic engine component fail on a vehicle still under 100,000 miles? What was the part? What was the vehicle? And what did they charge you to replace it? Sound off in the comments below, because your repair invoice is the evidence they are still hoping you never compare notes on. If you refuse to keep paying full price for an engine built with components that look like garden hose fittings, hit the subscribe button and join the resistance. Keep the old iron running. Keep turning your own wrenches. We will see you in the next one.